Alright, so let's do a video about the law of cosines. So here's your law of cosines. A squared equals b squared plus c squared minus 2bc cosine a, etc., etc. This is the version I remember. Now, why do I remember that version? Because look what's in that version. C squared equals a squared plus b squared. The Pythagorean theorem. And so the Pythagorean theorem, technically, if you want to think about it, is actually a special version of the law of cosines. For example, this would be little a, little b, little c. So if I had c squared equals a squared plus b squared minus 2ab cosine of c, but c is 90, and remember the cosine of 90 degrees is 0. So in the case of a right triangle, when you work this out, cosine of 90 is 0, 0, that's all being multiplied, all that drops off, and you're just left with this. So Pythagorean theorem really is a special case of the law of cosines. And so you can use any version here. It doesn't matter. Really, it's just one version. It's just it's cyclical, and so you can kind of interchange the sides however you wish. So let's look at two examples. There's basically two flavors of problems you get with this. All right, and now this works for any triangle, but you have to have a kind of a certain setup. So in this setup, it doesn't say what it wants us to solve for, but here's the point. It's not a right triangle, or at least we don't know for sure it's a right triangle. So therefore, we should not use right triangle trigonometry, because we don't know for sure. Also, look, I have this angle, but I don't know its side. So I don't have that pair, if you will. I have this side, but I don't know its angle. Likewise, I have this side, but I don't know that angle. So I have no corresponding pairs, if you will. If I had corresponding pairs, I would use the law of sines, because the law of sines uses an angle and its side. And you should always do that, because the law of sines is quite frankly easier than the law of cosines. So I don't, and so let's just say I wanted to solve for a here, and I could do that using the law of cosines. And so a squared equals b squared plus c squared minus 2 times bc times the cosine of angle A. Now I'll just start filling stuff in. A squared equals b squared, that would be 21 squared plus 42 squared minus 2 times 21 times 42 times the cosine of 39. All that can be worked out, and if I was solving for a would be the square root of all that stuff, 21 squared plus 42 squared minus 2 times 21 times 42 times the cosine of 39. So if I calculate that real quick, I get 21 squared I get A to be equal to approximately 28.88. And I notice there should be a 42 there. I wrote just the 4. So there you go. So then I have A. So that's the law of cosines. That's one flavor. So you're trying to find a side. And again, I'm using the law of cosines. I'd rather use the law of sines. I can't use it. I don't have a corresponding pair. Another flavor. You're presented with all three sides and nothing else. Again, I don't know for sure this is a right triangle, so you should not use right triangle trigonometry. So no SOHCAHTOA stuff. However, again, look at it. I have an angle. I don't know the angle, though. I have a side. I have a side. Again, I don't know its angle. I have a side. I don't know its angle. So I have no corresponding pairs. So that means law of sines is out. which means law of cosines is in. Now, apparently, I want to find this angle C here as it's labeled. So since I'm finding angle C, I'm going to use the C squared version of the formula. So C squared equals A squared plus B squared minus 2AB cosine of angle C. Now, be careful. 8 squared equals 5 squared plus 9 squared. I flipped those around, but order doesn't matter on those, I guess. So, oh well. 5 times 9, 9, that's a 9, times cosine of angle C. That's what I'm trying to find. Now, do your algebra, folks. This is a minus. So, you know, when you're doing algebra, you add and subtract stuff over before you divide. And all of this stuff here is being multiplied by cosines. So, if I work this out, this would be 64 equals 106 minus 2 times 5 is 10 times 9, that'd be 90 cosine of C. So I'm going to what? Well, you're going to subtract 106, right? And so 64 minus 106, let's see here, negative 42 equals a negative 90 times the cosine of C. It's a negative 90 times the cosine of C, so the opposite operation is divide. And so negative 42 divided by negative 90. And, or I could just leave it as a fraction, I guess. I'll leave it as a fraction for now. That's going to reduce down to 7/15. Negative divided by negative is positive. Cosine is C. So to solve for C, you take the arc cosine. And so C is equal to arc cosine of 7/15. And so what is that? Survey says 62.18. And now I know that angle. And now that I know that angle, I could proceed. And actually, now that I know that angle, that gives me corresponding pair, a side and an angle. And so actually, if I had to continue on and find all the other parts, in other words, the other two angles, I'd probably use the law of sines to continue this problem on. But anyhow, so there is the law of cosines in action, two different kind of situations.